Okay, guys, during class, we didn't get to go into the details of analyzing certain aspects of some parabolas that are a little bit more complex than the ones that we graphed during class. So, let's remember that there are certain parabolas, a lot of them, but these parabolas happen to have their vertex away from the y-axis. And now that vertex can be anywhere, right? We also discussed how important it is to find the vertex first when we want to graph a parabola, and from there we could graph the rest of the parabola. So, in summary, the vertex is really important, but sometimes it's a little bit complex to find it, especially when we have our quadratic function in what we call the standard form. I'm giving you an example here, right? F of x equals ax squared plus bx plus c is what we call the standard form, with all the terms, especially taking into account that in this unit 3.3 we're including the linear term. So let me explain certain things that we can see here in this graph. You can see a parabola. This is the y-intercept. We're not going to pay attention to it at this moment, but we're going to pay attention to the vertex. Now, there is a line that we call the axis of symmetry that, if you cut the parabola into parts, you could see two identical parts. That is what we call the axis of symmetry. It happens to be a vertical line, which means that the equation of that line is of the form x equals and a number. Now, the thing is that the axis of symmetry can be calculated taking into account, as you can notice, the coefficients of the linear term and the coefficient of the quadratic term. So, as you can see, this line right here has the equation x equals, and this is how we find it, by doing the following operation. The opposite of b divided by twice a. So, I'm going to present to you that the vertex has coordinates x and y, and I just use this subindex to indicate that it's the x and y of the vertex. So the exercise we're doing right now is we're going to find that line, the axis of symmetry, and the vertex of the function 2x squared minus 4x plus 5. So let's begin with the axis of symmetry. What I indicated here is that this same line is the axis of symmetry. So what do we need to do? Let's identify what b is and what a is. From this, let's indicate that this is f of x. It's a quadratic function. So what is b? b is 2. And what is a? A is the coefficient of the quadratic term. Oh, sorry, I made a mistake in here. So b is the coefficient of the linear term, which happens to be -4. And now a is the coefficient of the quadratic term, which in this case is 2. Now we're going to use this formula. We're going to take the opposite of b. If b is -4, then the opposite of b should be 4. Divided by 2 multiplied by a, which in this case is 2, so it's 2 times 2. Eventually, when you make the corresponding operations, it's 1. So the axis of symmetry is the line x equals 1. Now, the second part of this exercise is finding the coordinates of the vertex. As you can see, the x value of the vertex is the same value of the axis of symmetry, so we already have it. It's the same thing as doing x sub v. So we need to find out the corresponding y value when x is 1. So we are going to evaluate this function when x is 1. So it means that we are going to plug this value in here and in here, and let's see what we get. So f of what? F of 1, because that is going to be our input. We're going to plug in x in here. So 2 multiplied by 1 squared Then we subtract 4 multiplied by 1, and then we add 5. Now we run all this operation taking into account the order of operations, or PEMDAS for some of you. So we got 1 squared is 1 times 2, it's 2, minus 4 is negative 2, plus 5, so it is 3. So the vertex of this function will be located at x is 1 and y is 3. And we're done. Now if you want to graph it, you will see, probably you might want to use Desmos, and you're going to enter this value, and you might confirm that the graph shows that the vertex is located at 1, 3. That's it.